Okay. Hi, everybody. Can you hear me? No, not quite. All right, I'll use this mic. Hello. Everybody awake after lunch? I'm struggling, but I'm going to stay with you. All right, so as Aran said, I'm here to channel AIARPA. And the reason for that is that I work at MIT Lincoln Laboratory. We are a research laboratory operated by MIT to support the federal government in defense and intelligence and in other sort of national security concerns. And what I want to talk to you about today is how we can leverage cloud computing to do our nation's most sensitive and important work. So to give you a little background, what is AIARPA? It has ARPA in it, so you might think it's related to DARPA, and indeed it is in spirit. So the idea is that we have this vast intelligence community. There's 16 agencies in the United States intelligence community. It's not just the CIA and the NSA, though there are 4 big agencies, the NRO, the NGA, do satellite stuff, and then obviously NSA and CIA. But there's a whole bunch of other ones all across the federal government. And AIARPA's job is to do advanced research the same way that DARPA does for DoD to help to make these folks' job easier. And as you can see, it runs the gamut from homeland security to satellite and space data processing to human intelligence. All of that different stuff requires a lot of data processing. And the way that we have done that traditionally is by building out big private data centers. And more recently, the intelligence community has adopted cloud computing. And what we want to figure out is how to make that adoption of cloud computing keep going and not stagnate, and how we can make it more effective going into the future. So AIARPA and our program manager's name is Carrie Long, have this vision for how we can do this, and it has a cute name. It's called Classified as a Service, or CLAS. And so the way that we do this today is that we take our sensitive computing needs that the intelligence community has, and we put them on these private, isolated data centers. In the past, those were operated and built by the intelligence community or by contractors, and more recently, we've moved to farming that work out to actual commercial cloud providers. So there's this thing here called C2S, which is a commercial cloud solutions program, which basically has built a copy of a handful of Amazon data centers and then connected it to our classified networks. The problem with this, even though it's been a big boon for the intelligence community, because let me tell you, I've been working in this area for a long time, to see the ASCII art of the Amazon AMI fly by in a terminal on one of these classified networks was like a total anachronism, a future anachronism to me. I was like, oh my gosh, I'm seeing the world that I don't usually see in this antiquated classified environment. You know, there's a major influx of new innovation. But how do we get this to scale, right? We have a handful of data centers, but we don't have in a very, very large environment. We don't have the latest and greatest technology, even though it was a dramatic improvement over where we had before. So the idea is, can we actually strongly isolate our sensitive workloads in a public cloud alongside of other public cloud customers? And what we want to understand is how to do that such that we can get the scalability, flexibility, and all the benefits that we get from doing cloud in the commercial or in the open space. And so what we need is integrated hardware and software that creates a security architecture that allows us to have that little red line around the classified IC customers that's really powerful. So what I want to explain to you now is what concept we want to enable, and then how do we replicate what we have today. So the way that we do this today is with our traditional big fences. We have gates, guards, and guns, and we have our data centers and rooms with intrusion detection and things like that, and we keep what we think are the bad people out of those rooms. So there's a whole class of attacks that we ignore surrounding physical access, side channels, and so on. The other thing that we use is very, very expensive. I want to say this box here probably costs upwards of $20,000, $30,000. And that is a NSA certified network encryptor. And so what it does is it takes anything that goes through it and encrypts it in a very high assurance manner using keys that it got from the NSA. And that's good enough to protect whatever comes out of that thing to go over open communication lines where it could be intercepted by an adversary. And then the last thing that we do to secure our environments is we fill out giant stacks of paperwork to do things like FedRAMP. We go through all of the controls that NIST specifies, and we document all of that to show that we're doing a good job with security. So what we want to do is take some of these properties and how we're doing isolation today and make them more dynamic. And so what we want to enable is a cloud environment like this, where we have the cloud here, we have the NSA, they want to rent a computer, let's say a bare metal machine, And they want to be able to do that alongside of our friends, the Russians, who are renting computers in this environment as well. We want to do our sensitive processing on that node. We want to release it, give it back to the cloud provider, and then have them rent it to the Russian government next. So if you're a security person, this is absolutely insane. This is extremely, extremely risky. And so what we need, is it possible for us to do this with today's architectures? No. Categorically no. Is it possible for us to run a classified US intelligence community VM alongside of a VM run by the Russian government? Absolutely not. So what we want to understand is how can we actually get there? So when we look at today's systems, they're kind of a mess. Right? As we saw with this recent Supermicro story, the motherboards are very complicated. There's lots of I/O and different channels by which you can inject information or potentially leak information. And there's also a whole bunch of state. There's lots of different storage, flash devices on traditional motherboards, and these are all things that we need to account for as we take in a machine and we're going to essentially trust it to do our processing, and when we sanitize and give back those machines when we're done. So those are the concepts that AIARPA is interested in understanding. How can we design hardware and software that works together to make this process of getting nodes and giving them back more secure, such that we can do this kind of insane concept that I just talked about. And then lastly, I want to talk about sort of the business model, or the transition model that AIARPA sees for this. And the basic idea is that we want here in the blue box that you see on your right, or is that your right or left? Don't ask me to check, is that we want to do some rapid prototyping to see if we can demonstrate some of these concepts. Can we actually build server hardware and a software stack that enables this kind of isolation, use all the latest information we have on the threats that are coming out, and pull in innovations from across the community, from academia, from government labs, from the commercial sector, and so on, and put that together in a novel prototype. And then use that to demonstrate to, let's say, large commercial cloud providers that are interested in adopting this kind of technology, and show them how to do it. And say, if you implement things this way, if you could actually attest every last piece of flash on your device, then you're in a much better position. We also need to design and implement a standardized way of evaluating how isolated these systems actually are. And so that's another major effort that we're trying to stand up right now so that we can understand if this is even feasible. And then the idea is, once we know what to do and we have a bar that we're trying to hit, a measurement methodology, then we can go to the public cloud folks and they can implement this in their already very rapid refresh cycle. And so if we are able to leverage that, it's a lot better than the traditional government acquisition process where it can take us 10, 20 years to acquire anything, which in this world would be completely irrelevant. So to wrap up, this idea of leveraging a public cloud to do very sensitive processing we think is the future for sensitive government needs. It's also the future probably for lots of commercial sector needs, like we talked about with 2 Sigma this morning, where we have still a lot of resources that could move to the cloud, maybe not all of them, but that we want higher assurance for. The commercial cloud providers are interested in capturing that market, so they're also interested. And then a lot of the technologies, many of which you're hearing about today, including things like the secure bare metal offerings, bump-in-the-wire FPGAs, and so on, that technology is maturing, and it's really becoming a reality that you could cobble together a system like this. So we need that assessment, and we're currently looking at how do we measure the isolation mechanisms and how high assurance or how much confidence we have in them. And then we also want to assess the covert storage and communication channels within the system to understand how leaky an isolated system like this might be. And so we're currently doing a study at MIT Lincoln Laboratory to flesh out an initial design for that rapid prototype demonstration system, and we're developing that assessment methodology. And we're looking to you to help for us to find partners who are interested in providing designs, technology, approaches, assessments, and so on that help make this dream a reality. So we're talking to the major cloud providers, and we're also looking at the mass open cloud partners as a way of getting more information about either needs or technologies. So please come and find me. I'll be here for the rest of the day, and I can be happy to relay your thoughts and concerns back to AIARPA and help get you involved in this exciting program. And with that, I will close. Thank you very much.